I'm so excited to be here at FireConf or Firebase Summit. Thanks so much. I hope you've been having a great time. I certainly have, just talking to everyone. So today we're going to talk about serverless payments. So how to manage payments in your application. We'll be using Firestore and functions to do this. And there's a lot of different ways that you can manage payments, or a lot of different payment types. So maybe something like, oh, also, I'm Susan. I didn't introduce myself, and I work on Firebase, and I'm a software engineer. Sorry. Excuse me, it's been. Anyway, that's me. And yeah, so there's different ways you can manage payments. So we have our something like a store, maybe a physical object or good. Something like an on-demand economy, maybe Uber or Airbnb that has a delivery or a service. And then there's stuff like software as a service. So maybe something like a cloud service for developers, which might be Firebase. So I have a really great idea for an app that I would love to create. It's called Goat Landscaping. I don't know if y'all have heard about it, but a while ago I bought about 50 goats, just for fun. I just wanted them. And I thought, well, I could make some money off of the goats. And I had a great idea that I would make an app that would bring the goats to people's lawns. So how this will work is you'll contact us on the app and say, I want the goats to come. And we'll schedule a landscaping that works for you. So the goats have a very rigorous schedule. And you have a rigorous schedule, too. So we'll figure out some time. From there, the highly trained goats will come and manicure your lawn. So they'll come and eat all the grass and make everything nice and clean. It's very environmentally friendly. And step 4 is profit. So somehow we're going to be able to get paid for this. So what a great idea. I've already built out an application. And I've added in Firebase authentication, obviously. And I've built out the scheduling portion of the app. But the final step in this process is managing the customer payments. So how are we going to charge customers for this service? So when thinking about this, there's a few different ways to handle manage payments. So we could maybe start storing credit card information, keep track of all the different credit cards that exist, like MasterCard, Visa. Maybe we even want to accept cryptocurrency. I live in San Francisco, so that might be necessary. Things like that we have to keep track of. Even sort of like fraud. So I hope that that won't happen, but maybe there's some fraudulent activity, or credit cards that are out of date that are trying to be used. So I could build my own payment system from the ground up, but as you can see, that gets me further and further away from the goats, which is my true passion. And so the other option here is to use an existing payment processor, so something like Stripe or Square or PayPal, in order to handle the more actual talking to credit card APIs process. This way, we don't have any credit card information that we store on our backend. We let Stripe or Square do what they do best, and our applications can do what we do best, which is goats. So we've used Stripe for this example, but you don't have to. You could use any of the payment processor that you want. And the way that this will work is we'll create a Stripe customer. Then we'll add a payment method, so a credit card. We'll make a payment. And then, hopefully this won't happen, but we'll also show you how to handle a refund, or at least make sure your refunds are secure. And then finally, you'll be able to get your lawn mowed. So the first step is creating a Stripe customer. So how this will work is the client will log in. So a user is going to log in for the first time using Firebase authentication. Once the user logs in, we'll trigger a cloud function. The cloud function will then talk to the Stripe API and create a customer. Once we get the data back from Stripe, we'll save it back to Firestore. We need this data in Firestore to make our next API calls to Stripe, so we need to keep track of it. So let's look at what this will look like in code. Don't worry, all this code is in the function sample repo and in our GitHub, so you'll be able to find it quite easily. And it's linked at the end in the Firebase app. So this function is called createStepCustomer. And we're triggering this function on the creation of a user. And you can tell by that by seeing the functions.auth.user and then on create. The function gives us the user object, which we can have access to fields like email and user ID. So in order to create a Stripe customer, we're just going to call the Stripe API with the email address that the user logged in with. We want to wait for the data to come back because functions will just continue running unless we have that await there, and the data won't actually get back to us. So that await is actually quite important. Once we have the customer data back from Stripe, we need to save it to Firestore so that we can use it later. So here we call the admin Firestore SDK, and we have the collection Stripe customers. This is where we'll keep track of all of our customers. And we'll have documents for each user, and the document ID will be the user ID that authentication gives us. Now that we have our collection and document, we set the customer data by saying the customer ID and the customer ID that we get back from Stripe. So let's look at what this looks like when we actually have our application. So here you can see we're logging into the app. Just going to go ahead and sign in with Google. This is through Firebase authentication. And then we'll choose the correct account. This Firebase Firecast seems good. And this is triggering the cloud function and talking to the Stripe API on the back end. You can see we're adding a new document here in Firestore. And when we click on that document, you can see the customer ID that we got back from Stripe. OK. So now we've logged our user in, created a Stripe customer that's linked to our user. The next step in the process is to create a Stripe payment method. So this allows us to have a recurring charge on the user, or charge the user more than once, not exactly a recurring charge. It is possible to have a one-off token created, but we want them to have a card on file. So we're going to have them have a card on file. The way this will work is the client will create a token via the Stripe SDK. So as I mentioned earlier, we could do one-off charges, but that would mean that every time a user wants to use our application, they have to re-enter in their credit card information and use that to talk to Stripe. Since we hope that our users will be coming back, we want them to have our card on file. So we ask Stripe to give us a token, which we can then use to exchange for a source, which is Stripe's way of a payment method or a credit card. So we take this token, and we store it to Cloud Firestore. Once we have the token in Cloud Firestore, we trigger our cloud function. The cloud function talks to the Stripe SDK and takes the token that we've created and the customer that we made in the first step of this process and creates a source for that customer. So once we get all of that data back from Stripe, we store the data to Cloud Firestore. So let's look again at what this will look like in code. So we have our function here, add payment source, and it's a Firestore function. So this gets triggered whenever we write to this location in Cloud Firestore. The location is Stripe customers, user ID, tokens, auto ID. Those user ID and auto ID in there are parameters that we have available to us in the context. So by calling context.param.userid, we'll get the user ID that's being written to. And the auto ID, or context.param.autoid, will give us the auto ID that Firestore generates for us. We can also get the data saved to that location within this function by calling the change.after.data. So the first thing that we do is get the token. So that's the token that the Stripe SDK gave to the client. We'll get the token by calling change.after.data.token. So now with the token, we need the customer ID from Stripe. So we call the admin Firestore, and then we use the context.params.userid to get our exact Stripe customer from Firestore. We wait for that data to come back, And then once we have it back, we get the customer from there. So that's the Stripe customer that we saved earlier. We do this a little bit, so I've made a function called getCustomerID that takes in the user ID and will return the Stripe customer ID. So now, with our customer and our token, we can talk to the Stripe API and create a card source. We wait for that data to come back, and then we'll save it to Cloud Firestore. So here we're creating a sub-collection called sources. So we call the Stripe customers, which is the top-level collection we had earlier, the user ID, which is for this specific user, and then each user is going to have a sources sub-collection that will keep track of all their cards that they have on file. We'll make the document the response.fingerprint. The response.fingerprint is just a way of identifying the card that doesn't have private information. So we don't have to store any credit card information in our backend. We can store just the fingerprint and the response data, and that'll give us enough to create charges. So let's look at what this will look like in our application. OK. So we go in here, and we add a credit card. And you type in your credit card information. This is just the Stripe testing credit card. And we can see enter in this and click Done. This is getting a token from Stripe. And we say OK. It's triggering the function. We're talking to the Stripe API, and then writing the data back. And you can see it comes up here. If we go into our Stripe customers, you see a sub-collection called sources, a document with the credit card fingerprint, and some basic information about the card. So now we have our Stripe customer. And we've created a source, so a way for them to pay. The next step in the process is to actually make the payment. So Cloud Firestore, we ask for the payment to be made. And once the payment is requested, we trigger a Cloud function. Then, once we have the Cloud function, we talk to the Stripe SDK to actually process the payment. Once we get the data back, we write the result to Cloud Firestore. So before I go into the code here, I kind of want to talk about Cloud Function retries. Cloud Functions are guaranteed to run at least once. But sometimes they can run more than once. And in this particular case, that might be a really bad thing, because this is where we're actually charging our customer. So if our function runs more than once, and we call the Stripe API more than once, it'll charge our users more than once, which is something we really don't want. So the way to get around this is idempotency. Idempotency is a computer science concept. Stripe uses it. A bunch of other places use it. And the concept means that no matter how many times a method is called, the side effects are guaranteed to only run once. So in our Stripe example, if we call the Stripe API with the same arguments, we'll only charge the customer once, because Stripe has set up some precautions that don't double charge if it sees the same inputs. So when using our function, we'll need to take advantage of this. So let's look at the code, and we'll see the idempotency come up as we go through it. So here we have our create Stripe charge. We have a function on create. So when this particular location is created, the document location that we're looking to is the Stripe customers with the user ID, the charges, and the auto ID. So the user ID is just the user that's logged in, and the auto ID is a randomly generated Firestore ID. So we get the same data and context from that. So the first thing we do is get the customer. This will allow us to talk to Stripe. So we need the customer to associate it with our Stripe customer. Then we create a charge. So a charge is made up of the amount, the currency, and the customer. So the user passes in the amount. We have the currency as a constant. And then we have the customer from the database. The next thing we need to do is set source or default. So the source is the credit card that we added. So maybe the client is requesting to use a specific credit card, or we need to use the default one on the account. So now that we've done that, we need to figure out what our item potency key is. So here, we're going to use the context.params.itoid. This is a really great item potency key because even if the function runs more than once, the auto ID that we have saved here won't change. So the document has already been written, and the function will just run more than once, and the auto ID should be the same. So this is a good choice for our item potency key. So now that we have our item potency key, our charge, we can create the actual charge on Stripe and actually talk to the credit cards and stuff like that that Stripe will do for us. So we call stripe.charges.create with the charge and the item potency key. And we wait for that data to come back. Once we have the data back, we save it to the database. So we say snap.ref.set and save the response back. Now, I've wrapped this in a try-catch because this code is really important. And if there's any error, I want to know about it, and the user wants to know about it. So in the case of an error here, I catch it. And then I make sure that the database is aware of the error. I'll also want the user to be aware of the error. So I've had a function here called user-facing error message that translates the error into something more readable. And that will be displayed on the client. So let's look at what this looks like in the application. So here we have a payment for the goat mowing. We're going to go ahead and click Pay. And it says Payment Success Complete. So we can now go in and look at our database. Oh, sorry. We'll look at our history so we can see our payment history. Now we'll look at our database, at our Stripe customers, and our charges. And we can see the charge here. Don't worry, it comes back in cents. So that's how the data is set up. The nice thing about having a charges subcollection is so that we can actually go and see that list of charges that we've made. The user can look at it. Often you want a history of your charges. And we can look at it as administrators and make sure that the charges are what they say they should be. OK, so this is great. We've built out a great application. Everyone's happy. There's never any problems. It's never raining. Our goats are never full. We're done. We don't. Thanks so much. No. So sometimes you need to handle a refund. It just comes up. And so the way that we'll do this via the code is the client will write a request to Cloud Firestore to ask for a refund. Since we don't want to just grant everyone refunds, we have this admin user who lives in our Stripe customers collection, and they can grant approval on refunds. So the admin will get to say, do you get a refund? Do you not get a refund? Once the admin has approved the refund request, we'll trigger a Cloud function. That Cloud function will talk to the Stripe SDK and process the refund. And then once we get the data back, we'll save it to Cloud Firestore. However, there's a bit of a security concern here. Hopefully, y'all will know, because we just had Mike and Todd's talk on security, and GDPR covered some security rules. But I've bolded it here, this admin user. If our security rules are open, anyone could make themselves an admin user, which means that you could grant yourself access to approve all of your own refunds, which would be bad. So what if we have this mean goat here who wants to come and write themselves as an admin? And we don't want to allow that to happen. So for the refund code, we have all of that on the GitHub, but I just want to highlight the rules that we put in place to prevent this case from happening. So here we have our security rules. And we're matching on the database. And we have hopefully have some other security rules in here. But I'm looking particularly at the Stripe customers. So we'll allow you to read from your customer data if you're the logged in user. So if you're trying to access your own Stripe customer data, you can read it. So the first line, if request.auth.uid, equals UID, that means that if you're the logged in user, you can read it. Now, if you want to write to that, we'll have the same, you have to be the user you're trying to write to. But we also want to make sure that you're not trying to change the isAdmin user setting. So you're not making yourself an admin. You're not able to change it. And the way that we do that is saying request.resource.data isAdmin user is equal to resource.data isAdmin user. The request is what's coming in, the request that you're trying to change. And the resource.data is what already exists there. So this will prevent you from making any updates on the client to your Stripe customers to the admin user setting. So that's a quick little tip on how to secure a user from changing themselves to be an admin. And it'll prevent that particular scenario. But there's a lot more to rules than just this. So I would recommend reading up on the documentation and checking out the other talks if you weren't able to see them. So today we've covered how to create a Stripe customer, how to add a card, a payment method to the Stripe customer, how to actually make a payment, and how to handle a refund. I hope that this was helpful, and I'll be in the lounge afterwards if you have any questions. And there's next steps here on the events page if you want to learn more or see the code. Thanks.